You're standing still. That's it. You're not doing anything dramatic. You're just standing inside a pressurized habitat on Pluto's surface, looking out through a thick viewport. And already, you're dying. Not from a meteor strike. Not from a system failure. Not from anything going wrong. Just from existing there. Because Pluto doesn't need to attack you. It doesn't have to. The physics of that world are so fundamentally hostile that the universe itself becomes the weapon. And today, we're going to talk about exactly why NASA engineers have quietly concluded that a crewed mission to Pluto isn't just difficult. It's in a category of danger that barely has a name. Let's go. Most people hear Pluto is far away and think, long flight, boring, uncomfortable. Fine. Pluto averages about 5.9 billion kilometers from Earth. To put that in a frame your brain can actually hold, the signal from New Horizons, traveling at the speed of light, takes over 4.5 hours one way. If something goes wrong on your spacecraft, you radio home. And then you wait 9 hours for the conversation to complete. That's not a communication delay. That's a death sentence with extra steps. Every Apollo rescue plan, every IS emergency protocol, every contingency in human spaceflight history is built on one assumption: help can reach you. On Pluto, that assumption doesn't just weaken, it evaporates entirely. You are more isolated from humanity than any human being has ever been. More isolated than the Apollo astronauts on the far side of the moon. More isolated than anyone aboard the Voyager probes, because you're alive and you need things. And the journey to get there? With current propulsion technology, that's roughly 9 to 12 years in each direction. Let that sit. 9 years in space. One way. Now you've landed. And the temperature outside your habitat is approximately minus 233 degrees Celsius. That's not cold the way a winter night is cold. That's cold the way a different phase of reality is cold. At minus 233 Celsius, nitrogen, the gas that makes up 78% of the air you're breathing right now, turns into liquid, then into ice. On Pluto's surface, nitrogen forms plains of frozen ice that ripple and flow in geological slow motion. Beautiful, surreal, and absolutely indifferent to whether you live or die. For engineering, this temperature creates what materials scientists call cryogenic embrittlement. Steel becomes brittle as glass. Rubber seals, the kind that keep spacecraft airtight, the kind your life depends on, crack and fail. Lubricants freeze solid. Electronics behave in ways that even their manufacturers can't fully predict at these temperatures. Every single component of your habitat, your suit, your life support system has to be re-engineered from the ground up. Not optimized. Reinvented. The suit alone is a nightmare that has occupied engineers for decades. A standard EVA suit functions in the range of minus 120 to plus 120 Celsius. That sounds extreme, but on Pluto, you're past the lower end of that range by more than 100 degrees. Any exposed joint, any uninsulated surface, becomes a thermal bridge that pulls heat from your body with terrifying efficiency. You wouldn't freeze slowly. The cold would reach you immediately. Here's where it gets strange. People assume deep space radiation is the big problem. Solar particles, galactic cosmic rays, that's the story. And yes, during your 9-year transit, radiation exposure would be extraordinary. Potentially 2 to 3 times the lifetime career limit for NASA astronauts, absorbed before you even land. But the radiation problem on Pluto has a second layer that barely gets discussed. Pluto has no magnetic field. No appreciable atmosphere to speak of. Its thin nitrogen envelope is so tenuous that during parts of its 248-year orbit, as it moves away from the Sun, the atmosphere literally freezes and collapses onto the ground. So on the surface, you have zero shielding. Galactic cosmic rays, the high-energy particles that stream in from supernovae across the galaxy, hit Pluto's surface unimpeded. And these aren't the solar radiation you've heard about. These are nuclei of iron, stripped of their electrons, accelerated to near light speed by stellar explosions thousands of light years away. They don't just damage Dina, They tear through it, through your habitat walls, through your shielding. The only real protection is mass, rock, water, regolith piled on top of your habitat. You'd need to build underground, immediately, before you could do anything else. And here's the twist. Pluto's surface doesn't cooperate. Scientists suspected it. New Horizons confirmed it in 2015. Pluto has a subsurface ocean of liquid water, kept from freezing by the slow decay of radioactive elements in the rock below. And we know this because Pluto's surface shows geological features that only make sense if something liquid is moving deep underneath. Cracks, bulges, evidence of a world that is, impossibly, still active. For a moment, the scientific community exhaled. This was extraordinary. This was a potential habitat for life. This was hope. Crisis averted. We'd found liquid water. That is not the full story, because that ocean is buried under hundreds of kilometers of ice. Getting to it, even with robotic missions, would require drilling technology we don't have. And the surface above it isn't stable bedrock. It's a dynamic, shifting layer of nitrogen ice and methane frost that could not support a permanent structure over the timescales a human mission requires. You can't build on it. You can't drill through it easily. And even if you reach the ocean, you're inside a world with no sunlight to speak of. Pluto receives 900 times less solar energy than Earth, and no viable path to power generation using solar panels. You would need a nuclear reactor, which you'd have to bring from Earth, which adds mass, which makes the mission more expensive, which makes the launch window harder, which circles back to the 9-year transit, which circles back to everything. It compounds. We've talked about physics, let's talk about the human being inside all of this. 9 years in transit, possibly with a crew of 3 to 6 people, in a volume roughly comparable to a large apartment. No privacy, no resupply, no rescue, no real-time communication with anyone you've ever loved. NASA's psychological research from Antarctic isolation stations and long-duration ISS missions shows that after roughly 18 months, crews begin experiencing what researchers gently call third quarter syndrome, a kind of hollowing out. Motivation collapses. Interpersonal tension escalates. The sense of meaning that drove a person to volunteer for the mission starts to erode. Now multiply that by 6 years. The astronauts who go to Pluto, if we ever send them, would be different people when they arrive than when they left. Not metaphorically, neurologically. Extended microgravity causes measurable structural changes in the brain. Visual impairment, fluid shifts, bone density loss that rehabilitation can only partially reverse. And when they land, the work truly begins. There would be no recovery period on Pluto. The moment they step out, the clock is running. The resources are finite. Every contingency takes 9 hours to discuss with Earth. Every decision is theirs alone. Here's the thing. NASA hasn't said never. Not quite. What they've said, through mission planning documents, through engineering assessments, through the quiet conversations between scientists who love this little world, is that Pluto represents a class of challenge we are not yet capable of meeting safely. And that's a completely different statement. It's not a door closed. It's a door that humanity hasn't built the key for yet. Pluto was discovered in 1930 by a 24-year-old amateur astronomer named Clyde Tombaugh, working at the Lowell Observatory in Arizona, hunting through photographic plates with a device called a blink comparator. He found a tiny dot that moved. That's all it was. A moving dot. 85 years later, New Horizons flew past it and revealed a world of staggering, heartbreaking beauty. Mountains of water ice rising 3,500 meters. A vast heart-shaped nitrogen glacier the size of Texas. Floating hills drifting slowly across a methane sea. A world that is completely, perfectly, lethally itself. And maybe that's the real answer to why we dream about going there. Not because it's safe, not because it's practical, but because there is something in the human animal that looks at a place that will kill you and says, I want to understand you. That impulse is not recklessness. It is the same impulse that sent Tombor back to those photographic plates, night after night, in the cold Arizona dark, looking for a dot that moved. We are not ready to go to Pluto, but we are exactly the kind of species that will keep asking when. If this felt different from what you usually watch about space, good. The universe is genuinely strange and genuinely dangerous, and it deserves to be talked about that way. If you want more videos that take the science seriously and don't simplify the awe out of it, subscribe. It costs you nothing, and it tells me to keep making these. Drop a comment below. What mission in the solar system do you think humanity is most unprepared for? Pluto? Europa? Venus? Something else entirely? I read every single one. And if this made someone you know think differently about space exploration, share it. The best conversations happen when more people are in them. See you in the next one.